Hello students, welcome back to Akshar IIT online classes. So as a part of a chapter is matter around us, we are discussing about the solutions. So students, solutions are two types. One are called true solutions and second one is called mixtures. And in the true solutions, we are already started. We have discussed some topic from the true solutions, right? So what are those topics? True solution, a homogeneous mixture of two or more components is called as a true solution. And true solution consists of mainly binary solution consists of mainly two components. One is called as a solute and second is called as a solvent. Solute is what? Which is relatively less in quantity, and solvent is which is relatively large in quantity. Right? Now examples: sugar dissolved in water, salt solution, lemon juice, urea in water, acetic acid in water. These all are examples for the true solutions already we discussed, right? Now, and we are also discussing about the concentration of solution. Concentration is what? What is the amount of solute? The amount of solute, for example, here if you take the sugar, what the amount of sugar that present in unit volume of solvent is called as a concentration of the solution. So, the amount of solute dissolved in particular amount of solvent is called concentration of solution. This concentration of the solution can be expressed in different ways, many ways. And we already discussed that mass percentage, volume percentage, mass by volume percentage we discussed. Okay. And now next we have some other methods of expressing the concentration of solution like mole fraction, molarity, normality and molarity. So students, here one thing you have to remember that here in your 9th class, in a normal regular school, in regular classes, regular syllabus, you have only mass percentage, volume percentage and mass by volume percentage is there. But you don't have the molarity, mole fraction, normality and molality, right? But this is a IIT foundation, right? So here we are going in some depth, which are not there in a regular textbook that we are going to discuss here. Actually, these topics you can see in the 12th standard, okay, like mole fraction, molarity, normality and molality. Okay, but here let us discuss about the mole fraction. So total concentration of here should be on me and my explanation, right students? So now let us discuss about the mole fraction. What is mole fraction? Mole fraction is nothing but the ratio of, the ratio of number of moles of component, means maybe solute or solvent, present in the total number of moles of a solution. Did you understand? No? Okay. Now I will explain. Listen carefully now. Let see, we have the solution, and solution consists of two components, solute and solvent, right? Now let the number of moles of solute, is denoted by Na. Let's think, we are denoting it by Na. Now similarly, the number of moles of solvent, let we denote it by Nb. So now solute and solvent, if they mix together, then what happens? That becomes solution, right? So now the number of moles of solution is equal to Na plus Nb, right? Now what is mole fraction? Mole fraction is nothing but mole fraction is equal to one of the component, maybe solute or solvent, to the total number of moles of solution. Means what? Na, this component, to the total number of moles of solution, that is Na plus Nb. Okay, like this also you can write, or if you want the mole fraction of solvent, then we can write Nb by Na plus Nb. Okay, this is a mole fraction. So you can clearly understand here. See here, the ratio of number of moles of that component to the total number of moles of all components in the solution. Okay, so mole fraction of one component, to the total number of moles of all the components is called mole fraction. Mole fraction is denoted by the letter called chi. It's a Greek letter chi. It looks like X. So now as you are in the 9th class, you can just call it as a x if you want, right? So x, and it has no units. So this is most important point, that mole fraction has no units. Why? Because it's a ratio. In the numerator and the denominator we have the same physical quantity, so that get cancelled, so there will be no units. Remember, it's a very important point. Okay, and mole fraction we have the two components, that one is solute and one is solvent. Solute is denoted by A, solvent is denoted by B, right? Now the mole fraction of solute can be denoted by C, XA. So you have to write Na here at the numerator, Na by Na plus Nb. Now mole fraction of B means what? Solvent. So you write Nb, B is here, so the numerator Nb by Na plus Nb. That's all. So that is a mole fraction of the solute or solvent. Okay, students, in the mole fraction we have one advantage is there. Okay, whenever you solve one problem related to mole fraction, after solving the problem, if you want to check whether your answer is correct or wrong, then you have one advantage, that is, if you calculate mole fraction of solute and mole fraction of solvent, if you add sum of these, you should get answer 1. If you will get answer 1, the meaning is that your answer is perfect. Clear? Now let us see, we solve some problems. So here, 2 moles of sulfuric acid is dissolved in 6 moles of water. Calculate the mole fraction of sulfuric acid. Okay, sulfuric acid and water. This is our problem. Okay, so see students, whenever you have to solve the problem, then first what is given, prepare the data. So what is given? 2 moles of sulfuric acid dissolved in 6 moles of water. Here sulfuric acid is there, water is there. It's a mixture of sulfuric acid and water. But sulfuric acid is 2 moles, means the quantity is less. So this is solute. And water is 6 moles. Okay, so it is in larger quantity. So this is solvent, right? Now number of moles of solute. Okay, so number of moles of solute, it is denoted by Na, right? Na is equal to how many moles? 2 moles. So write it 2. Clear? Now then what you do? Number of moles of solvent. Okay, so that is water. Nb, how many moles? 6 moles. Okay, now we want to calculate the mole fraction of solute, that is what? Sulfuric acid. Okay, that is Xa question mark, and mole fraction of solvent, that is water. Okay, denoted by Xb. This you have to calculate, right? So first what we do, we calculate the mole fraction of sulfuric acid. So in the previous slide already we discussed that Xa is equal to Na by Na plus Nb, right? Now here Na is how much? 2. So write it 2 divided by Na plus Nb, that is what? 2 plus 6. So that is 2 by 8. So it comes to 0.25. Okay, so how much it is? 0.25. Mole fraction of solute is 0.25. Now I want to calculate mole fraction of the solvent, that is water. So then what I do? Xb is equal to Nb by Na plus Nb, right? That is equal to, here it is what? 6 here. Okay, so first write 6 in the numerator, and again you write 2 plus 6. So this becomes 6 by 8, that comes to 0.75. So Xb is equal to 0.75. I got both the answers, that is mole fraction of solute, mole fraction of solvent. But I don't know whether my answer is correct or wrong. Yes, so I would like to check whether my answer is correct or wrong. So what can I do? So here I had said no, the sum of the mole fractions of solute and solvent should be equal to 1. If we get that, then our answer is correct. So now what we do, we check this mole fraction of solute and sum of the mole fraction of solvent. So mole fraction of solute is how much? 0.25 plus mole fraction of the solvent how much? 0.75. So 0.25 plus 0.75 is how much? 1. So hence, okay, my answer is absolutely correct. Absolutely correct. Clear? So in this way, this is a mole fraction advantage. Clear, students? Now let us see one more problem. You want to take the screenshot of this one? You can take the screenshot. Okay. Now let's go to the next one. Okay. So here you see, one more problem. If the mole fraction of sodium chloride in its aqueous solution is 0.4, means what? We have the sodium chloride solution. Sodium chloride solution means what? Water in which the sodium chloride is mixed. Okay. So that solution is called the sodium chloride solution. Here, the mole fraction of the sodium chloride solution is given as 0.4. Now asking to calculate mole fraction of water. Okay. So see student now, solution. Alright. What is given? Mole fraction of sodium chloride, that is solute. Okay. So write mole fraction of sodium chloride. Okay. So sodium chloride, that is Xa, is equal to 0.4. This is given. Now they are asking to find, calculate the mole fraction of water. So what is that? Mole fraction of water, that is denoted by Xb. This you have to calculate, right? So how can you calculate? Very simple. Just now I give one formula that, okay, sum of the mole fractions of solute and solvent should be equal to 1. Yes. Now substitute in that Xa, so that is what? 0.4. So in the place of this one, write 0.4. This we don't know, so write this as it is equal to 1. Now this you keep mole fraction of solvent here only 1, this 0.4, take that side, minus 0.4. So that comes to 0.6. Over. So therefore, okay, the mole fraction of solvent is 0.6. How easy? Yes. So students, this is about the mole fraction, one of the most important topic to find the concentration of solution. But actually remember that this topic is not there in your 9th class, but it's very important for IIT level. Okay. So students, practice the mole fraction, definition, formula and numericals. Okay. Bye.